All right, y'all ready for this? This video should be, this section should be a little bit lighter than the last one. Fewer videos for sure, probably shorter videos as well, and also very useful. Okay. I like this class because we really get to focus on the things that are useful instead of the theoretical things that you're never going to use, which are useful in other situations, but not for any of us. So let's look at 1.7, where if we're fitting linear models to data. So we're going to start with the question of, well, what is a linear model? Well, we talked about linear models in the last section. We got two data points and we said, well, we can make a line with those data points, and then we can use that line to, answer questions about the situation. The thing is that in real life, there's not going to be two perfect lines to make a perfect, or two perfect points to make a perfect line. A lot of times we gather a bunch of data. We have a bunch of points and they're not all on the same line, but a line is still a good way to describe the relationship between the input variable and the output variable. So what we do is we just try to find kind of the best line with all those data points, and we use that to be our linear model. So in the last section, we theoretically found some lines. In reality, what we're going to do is, however, all the things that we used those lines for in the last section, we're still going to do. Usually we use computers to help us find the lines from all the data points that we collect. Lots of great stuff that we can do with this section, especially if we combine it with the previous section, and I'm pretty excited for some of them. Anyway, so let's start with an example. We have a table that shows the number of cricket chirps in 15 seconds and the air temperature in degrees Fahrenheit. You may or may not be aware that there is a relationship. I spoiled it for you. If you didn't know there was a relationship between these two things, I'm sorry I spoiled it for you. But let's go and do this. So we're going to use computers to help us. Go to Desmos and type in the data. So, okay, let's do that. So we need to type in the data. To do so, and the instructions are listed on your notes. I'm not going to read them, it's just the things that I'm doing. We're going to start by just typing table. As soon as I type the E, boom, Desmos creates a table for us. Maybe I zoom out just a little bit. And now we're going to put all of our X values. Those will be our inputs, in this case, the chirps on one side, and the Y values on the other side. So it's a little tedious, but let's just go through and type them in. 44, 80.5. And as fun as it is to watch me do this, I recommend just pausing the video and typing it all in on your own as well. The next one is 35, 70.5, 20.4, 57, 33, 66, 31, 68, 35, 72, 18.5, 52, 37, 73.5, 26, 53. I pet my cat and then I itched my nose, and then since I pet my cat, I had cat hair on my fingers, which made my nose itch some more. We have a disaster over here. So one of the nice things about doing this is that there's a little zoom fit button up here. If we click that, if we click that, there we go. It shows us our data. Okay. So it does zoom it. So notice that this is not the x-axis, right? This is a y value of 40. So none of this stuff got that cold, right? Our y-axis, our vertical axis is temperature. So we never had any data points under 50 degrees. That's why we're not even showing the bottom here. But we can see these points. And it seems like there's a relationship, right? Let's go back to our questions. All right, we did all this stuff for part A. Let's do part B. What variables might we use here? You could use X and Y, but let's not do that. That's boring. Let's say chirps C per 15 minutes. Our horizontal axis can be C. And we could say temperature T in degrees Fahrenheit. And we can, again, if we wanted to be really good students, we could type that in here. Our input is chirp C. Our output is temperature T. And we've got those labeled on the graph, kind of behind me and up here. Do these variables appear to be related linearly? Yeah, I'd say so. If you're curious about what doesn't look to be related linearly, we will see that in a future video. Okay, so definitely yes. You could add a yes with a few exclamation points. However many exclamation points you want to add is up to you. I'll choose 5. All right, let's try to find, this is the fun part. Let's try to find a line that fits this data well. So this would be a really fun thing if anyone's feeling adventurous to try to do on your own. Follow the instructions, pause the video and see and play around with it a little bit. It's pretty cool. What you can do is let's create a new line, y equals b plus mx. And we're going to add sliders for both b and m. And now we're going to just try to find different things that work. So we're going to need a higher b value because our line's really low. B is the starting value. We need to increase that starting value. So let's increase it to 10. Still way too low. 20. Still too low. 30. That's a little closer. But our line has to be a little steeper, right? The line's not quite steep enough. So you can also click and drag this around. Okay, maybe it's something like this. Make it a little taller. I don't know. That looks pretty good, right? You could make something that looks a little similar. Maybe you have a different guess. I don't know. That's close enough. That's a pretty good fit of a line. Y, or hold on, if we're really being good, right? C is equal to B plus M times T. Let's use the right variables. The chirps is going to be 32 plus 1.1 times the temperature in degrees Fahrenheit. Okay, let's write that down. Write the equation of your line below. The chirps is going to be 32 plus 1.1 times the temperature. This is just a quick interjection. Jason from the future is going to tell Jason from the past so that you from the future don't get confused. I flipped my variables here. T is the output. The chirps are the input. So write it down like this, not like I have it on my notes. I don't figure it out until the next video. So I'm coming back to let y'all